think the audio is on. Start
Which
recording.
audio?
Ours audio, I think.
No, it's not at all.
It's on.
Okay.
The link,
Sorry?
is it already started or we have to enter this link?
Oh, what's it? Meeting has already been started.
Started.
Yeah, it's
People are there already.
yeah. These are the people that is.
Oh, okay. Yeah, hello. Shall we start?
Yes, sir.
Yeah, okay. We are audible, right? So I'm Dr. Ramanujam. I finished my PhD recently. I'm a postdoctoral research scholar in Aerospace Engineering Department, working with Dr. Ranjit Mohan. With me, I have a PhD student. Lavish.
Hello everyone. I think I'm audible to everyone. So my name is Lavesh Goel. I'm a PhD scholar under Dr. Joel George sir. I am also in aerospace department working in flight dynamics and controls. So yeah, good to see you all.
So I think Rakshan and Dr. Ranjit Mohan might have taken a lot of sessions teaching you about rotorcraft, unmanned aerial vehicles. So he asked us to um, talk to you regarding if you have any doubts, you can clear. If you anything you want to learn specific, also you can mention. I think quad rotor is already covered. Um, do you want to revise?
Yes, sir.
Sir, am I audible?
Yeah, Shyam.
Yes, sir. It would be nice if you could revise the topic.
You want to revise the topic? Can you tell me like what Rakshan has taught you till now? I mean, what all topics did he cover? And then if is like what is there any doubt you have regarding any topic? So like I have a perspective like how can I start with the revision?
Sir,
Take a
actually, I
note,
didn't
just
attend
list out.
Yeah, just list out the topics if you have taken notes and then let me know if any specific topic you want to emphasize more. If you want me to emphasize more.
sir, I actually didn't attend the live session, but I saw the videos.
Okay.
Okay, no problem.
So I am having a little trouble understanding how the helicopter can take off and fly.
So, I mean, they have covered quad rotors, right? Yeah, I mean, you are mentioning quad rotors or helicopters because both are different.
Quadrotors only, sir.
Okay.
Because mainly when one side they are increasing the speed of the blade, it is going to the other side. That part I'm not able to understand.
Okay. Can I repeat once again? Sorry.
When the quadrotor is flying,
Quadrator. Okay.
yeah, on one side they increase the speed of the blades, and
Okay. Hmm.
the quadrotor goes to the other direction.
Okay. So he might have sketched you how a quadrator means looks like, isn't it?
Yes.
So, So quad rotor. So difference between quad rotor and conventional helicopter is conventional helicopter has one main rotor. Okay. And it has one tail rotor. Tail rotor is to counteract the reaction torque. So in multi-rotor or in a quad rotor, it has four. Quad means four. There are four rotors, right?
Yes.
The screen visible to you?
Yes, sir.
So you can see this is a view if you look from the top. Okay. So you have four rotors, rotor 1, rotor 2, rotor 3, and rotor 4. Okay. And let's say it is rotor 1 is spinning at speed, rotational direction, or in rotational speed of omega 1. Second rotor is spinning at omega 2. Third rotor is spinning at omega 3. And fourth rotor is spinning at omega 4. Okay. And all the four rotors have a similar geometry. Identical. All four rotors are identical. So it is arranged in so that one rotor spins in one direction, the opposite one, it will be spinning in another direction. 1 and 3 will be spinning in direction, 2 and 4 will be in a different directions. So if all the rotors spin at the same rotor speed, they produce a vertical force of same value. Okay. So if I call F is at 1, F is at 2, F is at 3, etc. as the forces, vertical forces produced by all the rotors. If they spin at same speed, effectively the entire quadrotor move only in vertical direction. Okay.
Okay, sir.
So this you understood, right?
Yes, sir.
If the force is equal to the weight, then effectively you are balancing the weight of the rotor with your aerodynamic force generated by all the four rotors, and it will stay somewhat hovering. So if I want to accelerate or climb in the vertical direction, the total force produced by all the four rotors, we call it that is thrust. Thrust is equal to F is at 1 plus F is at 2 plus F is at 3 plus F is at 4. Okay.
Yes.
Okay. So this is how it flies vertical only. So if I want to move forward, so what I have to do is I have to tilt the force vector. So you know about vectors, right?
Yes, sir.
So I need a vertical component of one force to stay high above the ground. And to move forward, I need a one more force component in the forward direction or whichever direction I want to go. So how we achieve is, so we spin one of the rotors or few of the rotors in a different speed. So there will be a difference in the forces generated by all the rotors.
Okay.
So in that way, it produces a force and a moment so that it will tilt. Effectively, it is tilting the force vector of the entire vehicle. So one component will balance your weight and one will give your force, propulsive force. Maybe I call it Fx in one direction. That's how it moves forward. So in this case, if you look into the top view of the quad rotor, if this is the x direction, so what I will do is I keep the rotors 2 and 4 in same value. To move it forward, I have to tilt forward. So I increase the speed of the third rotor and lower the speed of the first rotor. So in that way, it will actually tilt and start moving in the x direction. If I want to move only in lateral direction, I keep 1 and 3 the same speed of the rotor. And if this is my y direction, then I will increase speed of the rotor 4, so that the FZ, the vertical thrust produced by the rotor 4 is higher than
Okay.
second rotor. Second, I will lower it. So it will start moving in lateral direction. It will shift.
Okay.
And I think Rakshan might have explained you how the RPM of the rotors are controlled, like electronically, electronic speed controller, battery. The avionics part, I think, I assume he might have covered it. Isn't it?
You can speak actually, otherwise it will be monotonous. I mean, if we just speak. If you have any doubt, it would be better for us. Yeah, I think Chandrasekhar has some doubts. Yes, please go ahead.
Sir, I have a doubt. What is the necessity of clockwise and counterclockwise direction rotation, sir?
It is
In
mostly
quad rotor.
the torque. See, when the rotor spins, you feel that, see, the reaction produced by the rotor. So to cancel out, you have to spin it in the opposite direction, nothing else. So if you look in the helicopter, a conventional helicopter, big helicopter you have seen, there is a one main rotor. So you might ask, what is the need for the tail rotor? Why do you need a tail rotor? The one which is at the behind.
Oh, okay, sir.
Here, if you, and you might have seen some other helicopter with the two rotors. Have you seen such a helicopter?
Then we go to next switch. Just click about this new. Oh, discard. Yeah.
Okay. Single main rotor. Helicopter. So I'm sketching a side view. Sorry, my drawing is not that good. I hope clear to you. So you might have seen something like this, correct? Mostly you see such a helicopter. So this is a main rotor. We call it main rotor, and this is a tail rotor. So most of the forces is produced by this main rotor. The way it works when compared to quad rotor is little different. I hope Professor Ranjit Mohan might have explained you. Here the tail rotor. So whenever the main rotor spins, there will be a reaction which is seen by the fuselage or the when you sit inside the cabin, you feel like without a tail rotor, this will start spinning in the opposite direction. When main rotor spins in clockwise direction, the fuselage or the cabin where you stay will start spinning in the opposite direction. Okay, so to counteract that, there is a tail rotor. This rotor will produce forces in the lateral direction, and by manipulating this either speed or there is something called collective pitch of the tail rotor, you can actually counteract this reaction torque. This is single main rotor, and there is a coaxial rotor. So one problem with this single main rotor is the tail boom. This section is actually quite large, so it occupies some space. Okay, and the force produced by the tail rotor is not useful in the lifting the entire aircraft or rotorcraft. So they have one more idea of this is a coaxial rotor. We might say a tail feature, it may be, but bit shorter. And you have two rotors here. So one will spin in one direction, the other will spin in the opposite direction at same speed. The RPM of our top and bottom rotor are almost same. Same, it is same, mechanically arranged so that it is same. So that it cancel out the torque almost. So in quad rotor also, if you have four rotors, similar thing. So you arrange the rotors and the direction of the rotors such that it cancels out all the torque. So by only manipulating the thrust produce all the rotors, you either move up or move forward, lateral, or do any maneuvers. I hope it answered your question.
Yes, sir. Understood, sir.
Okay, thank you.
Thanks.
Any other doubts?
Sir,
Yes.
sir, in some planes, they can point the uh, nozzle downwards so that the plane will hover in one spot. What method that plane will use to counteract torque produced by the nozzle? Because nozzle is in the back of the plane and it is perpendicular to the ground.
Actually, it doesn't create any reaction torque. It just actually it's jet moving in the direction downward direction. It don't have a torque, not like in a helicopter or quadrotor.
Okay.
We don't have that problem. But actually, those thrust vectoring, it's called thrust vectoring. So compared to a helicopter or a quadrotor, hovering using that method is not efficient. So it will fuel. If you look into the fuel consumption will be much higher for that. They are
Okay.
only for moving at high speed in forward direction.
Okay.
Okay, yeah, good question. Anything else?
Anything else regarding avionics or like components of a quadrotors? Like, have you read about what are electronic speed controllers? How do they work and why they are necessary for drones? Can someone answer? Anybody? I mean, just take a guess if
Sir, electronic speed controller, we use them to control the speed of the motor.
hmm.
We require them so that we can vary the speed of each motor on the quadrotor, and so the resultant torque we can control and make the quadrotor move in the direction we want.
So how does it work basically, electronic? Like what signals do we give? I mean, it should get some signals, like for example, I am controlling a drone through my remote control. So if I give a command for example, pitch down, you know this pitch roll, you're right. So if I give a command of pitch down, so how that command is basically given to motors. I mean, just he explained, right? I mean, how the drones move forward. So basically, we have to increase the thrust of the back rear motors and then decrease the thrust for the front motors. So how that translate? I mean, our command, how does it translate through ESCs? Any idea? Have you read about PWM signals? Any idea about PWM signals?
No.
So basically, what happens is you have a flight controller like he is drawing. So flight ESCs take signals from the flight controller, which is in fact our given command. I mean, the commands that we give through our transmitter that goes to the flight controller, and flight controllers then give the PWM signals to ESCs, and there is also power given to ESCs through battery. So based on PWM means pulse width modulation. So you vary the width of the signal, right? Have you read about like duty ratio? What does it means and what is, I mean, if we vary the, for example, if it is a pulse and if I want to vary the width, for what time it will be on. So that is something controlling the width of the pulse is known as pulse width modulation. So flight controller basically what it does is it varies the width of the signals and then it gives to the ESCs. So what does ESC do is it converts the DC power that is getting from the battery to AC signals, three-phase signals to motors. And by varying, you must have read about this, how to vary the speed of a motor, AC motor. There are many methods like voltage control or frequency control, basically changing the phase angle between phases. You can control the speed of the motors. I think it's there in 11th and 12th, I guess, right? Can someone confirm? I mean, have you read about how we can vary the speed of motors using varying the phases angles between them, between the phases?
No, sir.
Yeah, so it works on the same. I mean, in a AC we have three phase, right? So if we vary the angle between them through pulse width modulation signals that we are getting from flight controller, we can basically change the speed of the motor. And that is done through changing the voltage that it's getting. So ESC's electronic speed controller, what it does is converts your DC power that you get from battery to AC signals, and then that's how you control the RPM of each motor. So did you get, I mean, how basically the chart flows, how it flows, your
Yes.
command to flight controller to ESCs and then to motors.
Yes.
So basically the principle is same in every kind of drones. You you have some kind of bridge between your flight controllers and your motors, whether it is helicopter or any kind of, for example, fixed wing also. So there, if you want to control the elevators and ailerons and all, there also you basically give the signals, PWM signals. So here is the basic flow chart, I mean block diagram kind of. So it will be helpful. Basically for every motor we have, you can have separate ESCs. Or there are some like nowadays we have also 4-in-1 ESCs in which like in a combined just one board and then you get all the four ESCs in one. So this is how basically ESCs work. So like
Okay.
in the similar manner, if you have any like specific doubts, any of any component, then you can ask. No doubts?
No.
Anybody else? Like is Sham only speaking? Like other people, I can see Sita, Bhanu, Chandrasekhar has already asked doubts. So if anybody has any doubts, please free to share. It might be possible that other people might have the same doubt. Uh, yes. Like what all can we cover?
Basically, I think there is just revision and
Yeah,
doubt
okay,
clearing.
okay. Sir told me some things.
Oh. Have you seen this quad rotor anywhere?
Yes, sir.
Okay, so try to fly it.
No, sir.
Okay, no problem.
So just to like, since you don't have any doubts, maybe we can discuss like there are quad rotors, like there are many type of drones basically. Like we have quad rotors. Drones are something called as in general. There is a wide variety of drones, which is also called as unmanned aerial vehicles (UAVs). So whatever thing which can fly without humans, it's called an UAV. So quadrotors is basically a subset of drones. So similarly, if you talk about helicopters, then also not helicopters, I mean helicopters without man. Or if you talk about fixed wing planes, model RC planes, or nowadays the most emerging field is basically vertical taking off and landing kind of planes. Have you heard about VTOL, like vertical taking off and landing
Yes,
planes?
sir.
So what it does is it takes off vertically like a drone. And since in fixed wing planes there is a limitation of runway, I mean you need a higher, like long runway to take off and land, right? But in
Yes.
quad rotors you can just take off vertically. But the drawback of quad rotors is its forward flight is not that efficient as compared to fixed wing. So that is why you may have seen that helicopters generally, they basically they cannot travel through continents like fixed wing can, because
Yes.
the efficiency of helicopters or quad rotors kind of thing are not very high. So basically there is a concept of vertical taking off and landing, which means you can combine both the features of quad rotors and then fixed wings, and then you combine both. So what you get, it takes off vertically, it transitions into a fixed wing in the middle of the flight, and then when it has to land, it transitions back to quad rotor kind of thing. So if you Google this American Navy, US Navy, they use this V2 Osprey. Have you heard
Yes.
about V2 Osprey?
Yes, sir.
Like other students, are they able to hear? They are not interacting.
Yes,
Panu,
sir.
okay. So yeah, let's keep it two-way communication. Otherwise, it would be kind of monotonous. So V2 Osprey is kind of one of VTOL, and it takes off vertically, and then there are many drop limitations of that. I mean, when it transitions, it requires a lot of fuel to transition. But again, there are advantages more than disadvantages. So the future is, I think, VTOL, because in cities, if you see, there will be air taxis, and also for that you won't have a long runway to take off and land. So, but you
Yes.
need a forward flight. So basically, VTOLs are, you can search about VTOL. I mean, just type in Google what are VTOLs, and in VTOLs also there are three different types. So I would leave that to you. Just search. I mean, what are the typical kind of vertical taking off and landing planes?
Sir, one doubt.
Yeah.
Why till now it is not possible or efficient enough to carry multiple passengers like passenger planes do, but in VTOL?
Actually, a bigger helicopter can work. Actually, if you look into recent technologies, people are working on it to take multiple passengers. Um, it will happen. It is happening actually. Maybe at least four or more than that.
So actually there are many trade-offs, because they work on batteries, right, instead of
Hmm.
engines. So
Yes.
if you have seen these electric vehicles that have been coming in this year or maybe last years, so there is a lot of development R&D uh, that has to be given while developing batteries, reducing the size of the batteries, and so, I mean, if you want to take more payload or more passengers, you need more battery. And batteries, if you keep more batteries, the weight of the batteries also comes into the plane. So there
Yes.
you have to basically find a very sweet spot in between, so that you know there is a balance between them.
So it's more of a commercial value.
Yeah.
So the company or the one who's operating it may not get much benefit, or he cannot make money, not much.
Okay.
Also quicker. So one problem is the VTOL vehicles are they cannot go high speed when compared to fixed wing.
Yes.
So have you traveled in a passenger aircraft?
Yes, sir.
Yeah. So I think the way I think it can even reach more than 500 kilometer per hour. That's actually a very average value. It can go much higher than that, much higher. So that speed VTOL vehicles cannot go. That's one limitation. That's one of the
Uh,
reasons. Cannot go very quickly, but there are many things which VTOL vehicles do that cannot be done using a fixed wing. So we fixed wing or the aircraft you travel, they have to be in at least, I mean, a minimum speed is required to stay float in the air. It requires some minimum velocity for a fixed wing.
That is there. I think somebody is writing the chat. Yep.
Yeah.
You can speak.
No, it's for the other people, I think.
Okay.
But VTOL vehicle can actually hover. Hover in the sense it at least can stay in one particular place for a long time.
Okay.
But it means minimum speed, minimum relative speed with respect to ground-based vehicle can be 0. It's not possible for a fixed wing. That's
Okay.
not. But it cannot go that fast. VTOL can compare to a fixed wing.
Yeah.
But it can carry passengers. So like I said, its commercial values are less. But people are working on it. There are people are working. It's called air taxi.
Okay.
You can search online if you want. See what is air taxi. You may find something similar to a quad or 4 rotors. Right now it's not available in the market, or you won't see it. In future it may come up.
Okay. Sir, I have another doubt.
Yeah.
Yes, good.
So I make RC planes,
Oh, good.
and
Great.
then for one project last year, and from then I have been trying to make one plane. It's called the Flying V. But one problem I'm facing is that it is not taking off, sir. Like I made conventional type planes before, and it's all flying. But
Okay.
this one, when I launch it, it either falls down or the torque is not balanced and it rotates and just crashes. So I was wondering if you could help me and figure out what the problem was.
I don't know. If
I mean, what kind of is it fixed wing?
flying V,
Flying.
Yes,
Oh, okay.
something like this, isn't
Like
it?
this, right?
yes, sir, yes, sir.
So if it is toppling, I mean, first of all, that you should check is the center of mass of the plane. I mean, just try to balance it on your finger and see where the center of mass is of the plane, CG, right? So that is the first thing after, I mean, after placing everything, your batteries and motors or whatever it is, you have to find out where is the CG of the plane is. So
Okay,
if you are like launching by hand, then it topples or then it falls back. So rolls or basically. So it might be a problem of the position of CG. Then you have to like arrange your components in such a way that the CG is like in the between, so that it's balanced.
so the thing is, I checked for the CG, and one modification that I'm using is that in the design they are using two engines on the back, but I kept only one very large propeller in the front on the nose.
So have you measured like what is the weight and then what is the thrust to weight ratio
Yeah.
required?
It may not be producing
Yes, sir.
stress.
The
That's one reason.
thrust, according to some calculations, the thrust is enough to move the weight, like more than enough, but the plane is not flying properly.
What I mean, do you have the values with you so that I can, I mean, because generally the thing is, if it's moving on ground, that is one thing, but in order to lift off, so whatever, if you are like in the boundary region, for example, if the thrust to weight ratio required and the thrust that your motor is giving is like very close, so it may not fly. It will not fly because generally the thumb rule is you should take more than, I mean, 1.5 times of the thrust to weight ratio that is required by the plane because the values that are given in the data sheet of a motor, they are lab tested values, so they are
Okay.
like ideal conditions they have tested. So in real world they might not give the same efficient thrust.
Okay.
Yeah, so
Sir, so
try to increase the propeller size. Basically propeller size and motors combination also play a role. Okay, so if you're using 3S batteries or 4S so there are many things that you should take care of and that can go wrong.
so I used the 3S battery,
Okay,
920 kV motor, and a 12-inch propeller.
okay, 12-inch prop, right? So I mean, yeah, you have to check basically the data sheet of motor, what kind of thrust it's giving. I mean, what is the value of the maximum thrust it can give. It will be available in the website from where you have bought it, or maybe it's also given sometimes in the motor itself.
That's one thing. The other thing is the wing design. So I am not sure whether the surface area or the chord and all whether you have chosen properly. The length of the wing. This length, and I'm not sure whether it has a simple shape like this or tapered wing. I'm not sure about it. So all these things matters. It should narrow the estimate of what the lift produced by the wing for a given propeller combination. Like you said, you have to find out what is the thrust produced by the propeller. Then accordingly, you should have some estimate. Is it something new you are trying?
Yes, sir.
Okay. CG also, like you said, I think you have to check with all the CG. So
Yeah,
that
there
also
are many
definitely.
things actually that can go wrong actually. There can be many point of failures. So, I mean, do you know how to check, how to boil down to what motor propeller combination is best for your aircraft? So that is basically comes from the data sheet. You should know how to read the data sheet of a motor specifications. Can we
Okay,
open
sir.
Google Chrome here? I think we can. So I think I can show you one, just an example. Maybe. So T Motor is one of the websites. I mean, generally, uh, all the hobbies, and then we use also for. So, for example, if you see, so I'll give you an example of like one of the motor. So if you go to your parameter and then scroll so here you'll get all the dimensions of the motor, and then here if you see the data sheet, so you
Yes,
can
sir.
see here this motor is 170 kV. The voltage required is 48 volts. So 48 volts is like you can calculate how many cells you want. And then propeller combination is 20-inch propeller required. So if you choose these three things, okay, so at 50% throttle you will get thrust of 2 kilograms, and
Okay, sir.
current will be 5.4 amperes. So in this way, basically we choose generally. So this is P motor. Then basically you can look for any kind of motors that you. Anti-gravity motors are much lighter. So if you see any and go to parameters, then here you can see. If you take this motor, this is 300 kV, voltage required is 24 volts. So 24 volt means 6S battery. And if you choose a 13-inch propeller, and if you choose a 50, like for different propellers, it's basically the thrust values are different. Okay.
Okay, sir.
So I mean, like this you have to check out. And also then you have to take only 80% of this thrust because this is lab tested data.
Okay, sir.
Yeah. So keep a sufficient margin between what motor you're choosing.
Okay, sir. Thank you, sir.
Yeah.
Anything else?
So okay, I think if you have any doubts, you can ask. Otherwise, we can wind up the session.
No doubts.
Yeah. Go ahead.
Okay, then see you guys. All the best.
Sir,
Yeah. Chandrasekhar.
sir, one doubt, sir.
Yeah.
Is this our last class, sir?
Not sure. I think that I have to confirm with Professor Ranjit Mohan. Mostly. You might know the schedule, right? Did they say this is your last class? I think you'll be informed.
Okay, sir. Sir, then another sir. If we change in the propeller diameter, the size, sir, there is a change will be in a quadcopter, sir, in that fly lifting.
Yeah, if you use a larger propeller, you will get more force in the vertical axis. That is thrust. Yes. Accordingly, power also.
Sir, and how the air disturbance are the managed in a quadcopter, sir? Because in planes means that the airfoil shapes, so they can nullify the disturbance. How in quadcopter, sir?
The propeller, if you look closely, it will have an airfoil shape. I am not sure whether you have physically seen a propeller. So it looks from top view something like this, isn't it? So if you cut this section, okay, this section will have an airfoil shape, but it will be smaller. So in fixed wing or a bigger plane, that the smooth shape, streamlined airfoil shape, it be very clear to us. In propeller, it's very small, so it's not that easy to notice. But it's an airfoil. If you look very closely, it is an airfoil like this. But dimensions are small. For example, if for a 2 kg or a 10-inch propeller, the maximum card may be within inch. That's it. And then you can imagine what is the thickness also. 10% of that, 10 or 20% of that.
Thank you, sir. Understood.
Okay.
Okay, then I guess we can wind up the meet. If you have any doubts, you can ask right now or
Sir,
yeah.
I just wanted to ask you if there's any way I could contact you in case I have more doubts regarding my project.
You can ask out. There might be some medium of communication between you and Rakshan, right? Professor Ranjit Mohan, sorry.
Or a Google form.
Okay.
Circulate a Google sheet or Google form to ask any questions.
Will it be available after the end of the day?
Maybe we can convey this to Professor Ranjit
We'll-
Mohan and then we'll let you know,
Yeah.
how you can ask your doubts.
Okay.
Basically, I mean, basically a kind of common classroom type where everybody can see their doubts and yeah. So we'll convey this and let you
Do
know.
you have anything specific in mind why you want to work on a project or something like that? Is it?
Yes, sir. For school wise, there are a lot of competitions coming up, and otherwise, I think it's a very nice hobby for me, and I'm interested. So,
Which class, if you don't mind, what class you are in?
11th, sir.
Okay, we'll convey this to professor. We'll get back to you.
Okay, sir.
If there is a Google form or anything like that, you just mention this. We'll see.
Okay.
Okay. Thank you, Shyam.
Thank you.
Okay, I think we can
Yeah.
directly.
So if no more questions, we will wind up.
Okay, guys, have a good day. And yeah, keep exploring.
All the best.
Thank you, sir.
Thank you, sir.
Yeah.
Welcome.
Okay.